Okay, Spartan fans, today we're going to talk about velocity and rates of change. Okay, the first thing we're going to look at is the instantaneous rate of change. And so hopefully this sounds familiar to you. Remember, instantaneous and average are not the same. Average rate of change is just the slope. We're talking about the instantaneous rate of change. So at a specific point A, okay, so hopefully you recognize this as the derivative. F prime is equal to the limit as h approaches 0 of the f of the a plus h minus the f of a all over h. Okay, so that's the first thing hopefully we remember. Let's look at displacement. Let's look at displacement. Okay, so your displacement over time that is delta S. It's going to equal to the f of t plus some delta t, change in time, minus the f of t. Notice there's no denominator. So this represents my change in position. And think of it as your ending position minus your starting position. That might be the easiest way to look at it. It's probably the easiest way to look at it. Okay, so now let's kind of put these two things together, instantaneous rate of change and displacement. And this is the velocity. Velocity is the derivative of position. Okay, so the derivative of position. Okay, so position is change of position, which is delta S, known as velocity, which is the derivative of the position with respect to time, which is the limit as delta t approaches 0 of the f of t plus delta t minus the f of t all over delta t. Okay, so this is the derivative of the position ds is the derivative of the position with respect to time. Delta t is the change in time. And this you should recognize. Normally it's x plus h. Here it's t plus delta t. This is the definition of the derivative. Instead of h, it is now delta t. So in the change, as the change in time gets closer and closer to 0, it's going to be how we find instantaneous speed, but in this case, we're finding the velocity. Okay, so I'm just gonna clearly go through, or clearly what I'm doing is going through a bunch of the definitions. And of course, watch the video, pause if you need to. Velocity and speed are not the same thing. Velocity and speed are not the same thing. Speed is the absolute value of velocity. Speed is the absolute value of velocity. Okay, and we just figured out that velocity is the derivative of position with respect to time. Speed is never negative. Velocity can be negative. Get pulled over, you're not going to tell the police officer, oh yeah, I was going negative 10 miles an hour. So we'll talk about what does it mean when velocity is negative. Maybe you can figure that out. Okay, last, before we start getting into some examples, is acceleration. Acceleration is the derivative of velocity. Acceleration is the derivative of velocity. Remember, velocity is the derivative of position. So it's the second derivative, we say. It's called the second derivative. So A for acceleration. So the acceleration over a specific period of time is the derivative of the velocity, which is the derivative of position. So this is referred to as the second derivative. It's not d squared. It's the second derivative of the position. Okay, so let's look at some examples and what does it mean when the velocity is negative. Okay, this is the graph of number 24 on page 131. Take a minute and draw that. The question asks, it says, again, I'm on number 24, page 131. The question says a particle P moves on a number line shown in part A, which is what we're doing, of the accompanying figure. Part B shows the position as a function of time. This is the position of the function of time. I did not draw, it's just a number line. I did not draw part A. Okay, so the question says, when is the particle moving left, moving right, and standing still? Okay, so this particle is moving left when the velocity is negative. Is moving right when the velocity is positive. And it is standing still when the velocity is 0. Okay, so first thing I'm going to do is find the slopes of all of these segments. So from 0, 0 to 1, 2, the slope is 2. Horizontal between 1, 2, and 2, 2. This is also 0 here. The slope from the point 2, 2 to the point 3, negative 2 is negative 4. How am I getting that? You know, when you have 2 points, you can just frankly count rise over run. And then from the 0.5 -2 to the 0.6 -4, the slope is -2. Okay. Positive slope from 0 to 1. So it is moving right. 0 included, 1 not included. It's changing position. In this case, it's going from right to standing still. And there is nowhere else on this graph where the slope is positive. It is standing still from 1 not included to, what is that, 3? Still from, nope, 1 to 2, as well as from x is 3 to x is 5. And then it is moving left when the velocity is negative. So the velocity is negative from 2 to 3, not included, as well as from 5 to 6, included. You can look at the speed. So this particle from 0 to 1 seconds is traveling 2 centimeters per second. Its velocity is 0 between, let's see, where are we? 1 to 2 seconds. This -4 means that this particle is traveling 4 centimeters per second. It's just traveling to the left. Okay, let's look at a problem where we have to find displacement, velocity, acceleration, etc., without the graph. So let's look at number 2 on page 129. Okay, so it says a particle moves along a line so that its position at any time t greater than 0 is given by the function. So this is its position, where s of t is position, is equal to t squared minus 3t plus 2. So part A says find displacement during the first 5 seconds. Okay, this is just a straight plug-in. Let's find the S of 0, which is 2. Let's find the S of 5, which is 12. So the displacement is 10. We are in meters. So it's just a distance. You're not dividing by anything, etc. So then it says the average velocity during those first 5 seconds. So remember, velocity is the derivative of the position, s prime of t, which is also ds dt. Okay, so let's find the derivative using the power rule. That's going to be 2t minus 3. And hold on a second. I'm going to have these switched. Part B is asking for average. Part C is asking for instantaneous. So what I'm finding is instantaneous. So the instantaneous, yeah, mess that up. Okay, so I'm just backwards. Part B wants to know average. Average is just slope. Instantaneous is the derivative. Okay, so this is going to be instantaneous. This is going to be S prime of 4, which is 2 times 4 minus 3, which is 5 meters per second. So this is all instantaneous. So this is part C. Part B wants you to find the average. And the average is just change in distance, whatever you want to call it, the displacement over time. The displacement is 10 meters. The time is 5 seconds, which is 2 meters per second. On average, this particle is moving at 2 meters per second. At 4 seconds, they asked you for 4. At 4 seconds, it's traveling 5 meters per second. So big difference between the average and the instantaneous. Part D, find acceleration. Okay, so that's going to be the derivative of the velocity. This is a little bit interesting. So if velocity is, the equation for velocity is 2t minus 3. Double prime. So doesn't that look weird? It looks like an 11. So the better way to write this is the second derivative over time. See how funky that looks? So that's why we don't write double prime. It's just weird. Second derivative, much nicer. Okay, so this is going to be 2. Power rule, derivative of a constant is 0. So the power rule is 2. That's just a constant. So the acceleration at any point in time on this for this particle is 2 meters per second squared. At what value does the particle change direction? So that just came up here. Changes direction when it switches from being positive to 0. It's changing direction when it switches from being positive, well, to being negative, but 0 in between. Right, between a positive number and a negative number is 0. So where is it changing? How about when the velocity is 0? So the x-intercept. How about 3/2? Last part, where is the particle when the position is a minimum? So this is going to be the S of 3/2. Okay, I think that's -1/4. Yes, it is -1/4. There are a lot more examples that we're going to look at involving acceleration, velocity, as well as marginal cost, but we will do that in the next video.